Welcome to Math 096 Lecture 28. So last time we were looking at section 5.1, and in section 5.1 we looked at the quotient rule. And one of the comments that I made about the quotient rule was that if you have something like x to the fifth divided by x to the third, where the higher power is in the numerator, the quotient rule really works well for that. But then I said that if we had these two powers swapped and the highest power was in the denominator, we weren't quite ready to use the quotient rule to do that problem in section 5.1. So now we're going to move on to section 5.2 and we're going to complete that story. So first off, if you don't have handout 26 printed and in front of you at this point, go ahead and pause the video, grab that handout, and then we're going to go ahead and complete that. We'll finish it off. So as you look at the bottom of the handout 26, you're going to see that the second to last item is the negative exponent rule. And the negative exponent rule is going to finish this story that we started up here. So let's go ahead and check out a specific example like x to the third divided by x to the fifth. Now, the first thing I'm going to do is simply use the rules of exponents, the definition of exponents, to go ahead and expand both of these. So x to the third, that's 3 copies of x. And x to the fifth, that's 5 copies of x. So now we can look at what's going to be happening in terms of fraction ideas and cancellation. X and x, those are going to cancel down to 1s, canceling, canceling. And now at this point, we've run out of places that we can cancel. So we've canceled all the x's that are possible that are common to both the numerator and the denominator. So if we look at what's left over, we have a whole bunch of 1s that are multiplied together in the numerator, so that's a 1. And in the denominator, we have a whole bunch of 1s times x, that's going to be x squared. So one version of this answer then is that x to the third divided by x to the fifth is 1 divided by x squared. And that's what I was talking about when we were talking about it back in section 5.1. But now, let's see what happens if I try to force the quotient rule to work here as well. So let's check out x to the third divided by x to the fifth, but this time I'm going to talk about it in terms of the quotient rule. So quotient rule says if I have x to a power divided by x to a power, I can subtract those exponents. So this would be x to the 3 minus 5 power. Well, if I subtract a 5 from a 3, I'm going to get a negative 2. So this is x to the negative second power. So as I look at these two pieces, once again, it looks like I got two different answers. But again, what's happening is that these answers have to be equal. So x to the negative second power is in fact the same as 1 over x squared. And if we generalize that, as we see on the page, if we have x to the negative m power, that's going to be the same as 1 divided by x to the m power. So as you look at this, that is the negative exponent rule. X to the negative m is equal to 1 divided by x to the m power. However, instead of memorizing it as a rule, my suggestion is to memorize this in terms of a process. So if you look at this x to the negative m, notice where that x to the negative m is in terms of a fraction. This is really x to the negative m over 1. So this x to the negative m is in the numerator. But over on the right-hand side, the x to the positive m is in the denominator. So a negative exponent moves this x that was in the numerator into the denominator. So what I have underneath this problem is a statement that starts off negative exponents, and what I'm going to write down is move things. And in particular, what we're going to find is that if you have an expression in the numerator, your negative exponent is going to move that into the denominator. It actually works the other way around as well. If you start with an x to a negative power in the denominator, that negative power is going to move it into the numerator. So whenever you're thinking about negative exponents, that would be my suggestion of helping you remember how to play with those problems. So with that in mind then, let's go ahead and check out our last rule, the fraction to a negative exponent rule. We have a divided by b to the negative m power. Well, this negative power is going to move things. So the a in the numerator is going to get moved into the denominator by this negative power. So we're going to have an a down in the denominator. And this b in the denominator is going to get moved up into the numerator by that negative power. So we're going to have a b up here. Now at this point, the negative has done his job. So he's out of the problem now, and we're simply going to have a positive m power. So that's our final rule. A divided by b to the negative m power is exactly the same as b divided by a to the positive m power.